In this video, we'll talk about how self-driving cars work and break down the technology that's driving the future of transportation. At the core of every self-driving car is the idea of autonomy. These vehicles can navigate and make decisions without human input. Self-driving cars operate by utilizing a mix of sensors, artificial intelligence, and complex algorithms. These technologies enable the car to perceive its surroundings, make informed decisions, and safely travel without human input. Self-driving cars use a wide array of sensors to see the world around them. These sensors include cameras, radar, LiDAR, and ultrasonic sensors. Each one has a unique role. First, let's talk about cameras. Cameras act like the car's eyes. They're used to detect lane markings, traffic signals, pedestrians, and other vehicles. However, cameras have limitations, particularly in low light conditions, and they can struggle to accurately identify objects at long distances. Next, let's talk about radar. Radar helps the car determine the location, speed, and direction of detected objects. Radar can transmit and receive signals over longer distances, making it useful for detecting objects at greater ranges. On top of that, radar works well in bad weather like rain or fog compared to cameras. Next up is LiDAR. LiDAR uses laser light to create detailed 3D maps of the car's surroundings. LiDAR sensors are highly accurate and allows the car to see objects in its path, even in low light. Lastly, let's talk about ultrasonic sensors. These sensors have the ability to detect objects at close range, like parking or monitoring objects near the car. Because ultrasonic sensors have limited range and resolution, it makes them less effective for detecting distant or small objects. Their performance is also hindered in adverse weather conditions like rain or fog. By integrating information from these sensors, the system can compensate for the limitations of each individual sensor, improving object detection, depth perception, and decision-making. The sensors are just one part of the equation. The real magic happens in the car's onboard computer, which uses artificial intelligence, or AI, to process all of this data in real time. AI algorithms help the car interpret the data from its sensors, make decisions, and react to the environment. For example, if the car sees a pedestrian crossing the street, it will calculate the best response, whether that's stopping or slowing down. Machine learning allows the car to improve its decision-making over time by learning from past experiences, just like a human driver. Self-driving cars also rely on detailed maps to navigate. These maps are incredibly precise, often accurate to within a few centimeters, and help the car know exactly where it is on the road. Using GPS and high-definition mapping data, the car can pinpoint its location and adjust its path accordingly. The maps are constantly updated, and the car uses sensor data to refine its understanding of the environment. The real challenge for self-driving cars is decision-making. As the car drives, it must constantly assess its surroundings, make predictions, and choose actions, all in a fraction of a second. For instance, when merging onto a highway, the car has to assess the speed and position of other vehicles, decide when to merge safely, and even anticipate the actions of other drivers. Self-driving cars use predictive models to estimate what other vehicles, cyclists, and pedestrians are likely to do. By combining sensor data, AI, and these models, the car can make the best possible decision to avoid accidents and navigate safely. Safety is a top priority in self-driving cars, and to ensure that, these vehicles are equipped with multiple layers of redundancy. For example, if one sensor fails, the car can rely on other sensors to take over. If the car's AI encounters a situation it cannot handle, it's programmed to safely pull over and stop until it can resolve the issue. Self-driving cars also undergo rigorous testing, both in simulations and real-world conditions, to ensure they can handle every possible driving scenario. Today, most self-driving cars are classified as Level 2 or Level 3 autonomy, meaning they require human intervention in certain situations, but engineers are working hard to reach level 5, full autonomy, where the car does all the driving, no human intervention required. While there's still work to be done, the technology is advancing quickly, and soon, these vehicles could be a regular part of our daily lives. Thanks for watching. If you enjoyed learning about how self-driving cars work, hit that like button and subscribe for more videos on the latest in tech and innovation.